everyone, welcome to Coders Camp. We are at 17th day of November LeetCode challenge and the problem we are going to cover in this video is unique paths. So we have already solved unique path 2 and 3 in our channel. So this is comparatively the basic version of those. And here the input given here is M and N, which is nothing but it represents the size of the grid or matrix. And we have to return the path from the top left corner to the bottom right corner. That is the number of paths that are possible or number of unique paths that are possible. So let's understand this with an example. So as per the problem statement, our robot is going to start from the top left corner and it has to reach the bottom right corner of the grid. So we have to return the number of unique paths we can travel from the top left corner to the bottom right corner. So as you all know, this is gonna have n number of paths, that is you can overlap the visited cells again and again. So you can't use a BFS because we usually take BFS technique to solve this kind of matrix problems when it comes to path or number of paths or something. But here we cannot use DFS or BFS to solve this because the paths are overriding. So you can't have a pointer visited to mark the cells we have already visited and only explore the cells we did not explore. That is how a BFS algorithm works efficiently. So if you cannot put a marker that the cells have been already visited, then in that case BFS is not going to work. Though if you try some technique to accomplish it, the time complexity is going to go infinite. So the best approach here is to use a dynamic programming solution. So we have covered enough dynamic programming solutions, either it is linear DP or two-dimensional DP already in our channel, but this problem is one of the classic problems where beginners can start with. It will really make you understand how to work with or what is dynamic programming and how to approach a two-dimensional DP problem by getting into this. So let's start. So before getting into the solution, as I always say, dynamic programming is nothing but solving sub problems, and from that solution we will solve another level of bigger problem and finally arrive at our bigger solution. So for any dynamic programming solution, we first have to solve our sub problem or the smallest possible problem and then get started with the higher number. So for this problem, what is the smallest possible problem we could get? So let's reduce the grid size. Let's consider we have only 2 cross 2 grid where the robot is placed in the leftmost cell and star is placed in the rightmost cell. So now what are the possible solutions for the robot to reach the star? So you can clearly know that robot can travel only towards the right side or downwards. So if it is traveling right side and downward, it is one path where the robot can travel, and the other path is it starts traveling towards down and then reaching towards its right. So it is another path. So the solution is 2 for this problem. So how did we achieve it? To reach this particular position, we have considered the movement of the robot from upwards and leftwards, because the possibility of robot can move towards right and down. So for a cell, a robot can reach from its top and its left. So this is the overall logic. So what are the possible ways that are there in the cell towards upside, and the left side will be the solution. So if you're not understanding, that is okay. Let's get into the bigger grid for better understanding. So let's consider we are having a two-dimensional array DP where each value of this DP array is going to hold the number of unique paths to reach that particular cell. So from that solution, we're going to build our solution towards the last grid. So let's consider and start iterating from 0, 1. So now from 0, 1, what are the unique paths, or how many number of unique paths for the robot to reach this particular position? So we obviously can say there is only one way, because the robot will move only towards right and down. In that case, the cell 0, 1 can be reached by the robot only by using one way. So our answer is clearly going to be 1. Also move on to the next cell, which is this 0, 2. So this also we clearly know there is only one path to reach that cell. It can be straight because it can move only towards right, not upward direction. You can say it can go down and go right, but it cannot go up. This is a wrong way. So if the only possible way is to reach that position is by moving towards its right. So similarly, all the rows in that first column, first row would be 1 only because that is the only possible path to reach that cell. Similar way, going towards down, this cells will also have 1 as the robot can move only towards downward direction to reach those cells. So now comes to our cell 1, 1. So to this particular cell, how many unique paths the robot can reach? So the robot can move towards right and then down. This is one path. And down and then right. This is another path. So there are two possible ways to reach this particular cell. So the value at this cell is going to be 2 because there are two unique paths to reach that particular cell. So moving towards the cell 1, 2. So 1, at 1, 2, what are the possible unique paths? So if you start doing it, you are going to start from right, down, and then right, that is reaching from this particular cell, or right, right and down, or down, right and right. So there are three possible ways. So I'm going to update 3 in here. Same way for this cell, it is going to be 4 possible ways because to this particular cell, you might have 3 possible ways. So those 3 possible ways will also applicable to its right cell because from this cell only you can move. But there is another up cell. There is one way to reach this cell. So from this cell, you can go down and reach this cell. So there are 3 plus 1, 4 ways. So now the formula is pretty simple. We are going to add the values at upward cell and left cell and update it here in this cell. So 4 plus 1 is going to be 5. 5 plus 1 is going to be 6 and 7. And updating the other cells as well in the similar way, it is going to be finally 21 plus 7 is going to be 28. So to reach this particular cell, you have 28 unique paths. So the solution is pretty simple. All you have to do is you have to have a DP array where you're going to update the values of the first column and first row as ones, and other columns will be calculated based on adding the diagonal values. So yes, all I'm trying to say here is we always fill in some values in the array and come up with a solution towards the end for any DP problem, but there is always a logic behind it. If you understand how we are deriving the solution for each sub-problem, you would probably crack this kind of problems. So yes, you can find the DP playlist where you can find very similar problems to this and start solving them to get good hand in your dynamic programming skills. This algorithm is going to work in big O of m cross n time complexity as well as space complexity. So let's go to the code now. So as I said, we need a two-dimensional DP array of size m and n, and we are going to update the values of columns and rows to 1. So now let us iterate the rest of the cells and update them by adding the diagonal values. So finally return the last cell of the DP where our solution for our bigger problem is there. So yes, let's give it a try. Yes, let's submit. Yeah, our solution is accepted and we have completed today's problem, and that runs in 0 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.